Take a close look at this equation. X squared equals 4x. It looks almost insultingly easy, doesn't it? Most students immediately divide both sides by x. Cancel the x on the left, cancel the x on the right, and we get x equals 4. Fast, clean, and x equals 4 really is correct. But it isn't the whole truth, because somewhere during that innocent-looking cancellation, another solution completely disappeared. Yes, we have just witnessed a mathematical crime, and the weapon is still sitting right in front of us. So, let's return to the crime scene. Here is our original equation. X squared equals 4x. And here is our prime suspect, dividing by x. Why is that dangerous? Because whenever we divide by x, we are silently assuming that x is not equal to 0. After all, division by 0 is undefined. So the moment we divided by x, we secretly introduced a new condition. X cannot be 0. But wait, did the original equation ever tell us that x couldn't be 0? No, we assumed it ourselves. Let's test what happens when x equals 0. Replace every x in the original equation with 0. On the left, we get 0 squared. On the right, we get 4 multiplied by 0. That gives us 0 equals 0. The equation is perfectly true. So 0 wasn't an intruder. It was a completely valid solution hiding in plain sight. Now let's replay the exact moment when the solution vanished. We divided both sides of the equation by x. But if x happened to equal 0, that step would become 0 divided by 0 equals 0 divided by 0. And 0 divided by 0 is undefined. It is forbidden in mathematics. Here is the important part. Dividing by x did not prove that x couldn't be 0. It simply made the calculation impossible when x was 0. In other words, we assumed that x was not 0 before we had checked whether 0 was a solution. Then, unsurprisingly, we found only the non-zero answer. That is how one careless cancellation gave us only half of the solution. So how do we solve the equation without making any answers disappear? We keep every possibility alive. Start with x squared equals 4x. Move everything to one side by subtracting 4x. Now we have x squared minus 4x equals 0. Factor out x. X multiplied by x minus 4 equals 0. Now use the zero product property. If two factors multiply to give 0, then at least one of those factors must equal 0. So either x equals 0 or x minus 4 equals 0, which gives us x equals 4. And there it is. The missing answer has returned. The complete solution is x equals 0 or x equals 4. And the graph confirms everything. The curves y equals x squared and y equals 4x meet at two different points. One intersection happens when x equals 0. The other happens when x equals 4. Two intersections, two solutions. Case closed. But don't relax just yet. The same trap can return wearing a better disguise. Consider, x multiplied by x minus 3 equals 5 multiplied by x minus 3. Both sides contain x minus 3, so you might immediately cancel it and conclude that x equals 5. And yes, 5 is one solution. But before cancelling anything, ask the question our investigation taught us. Could x minus 3 equal 0? If it can, then cancelling it could make another solution disappear. Set x minus 3 equal to 0, and we get x equals 3. But is 3 really a solution? Let's investigate. Replace x with 3 in the original equation. On the left, we get 3 multiplied by 3 minus 3. That becomes 3 multiplied by 0, which is 0. On the right, we get 5 multiplied by 3 minus 3. That becomes 5 multiplied by 0, which is also 0. So the equation becomes 0 equals 0. It works. Once again, cancelling an expression too quickly would have hidden a perfectly valid solution. The complete answer is therefore x equals 5 or x equals 3. Same crime, different disguise. So from now on, before dividing by a variable or an algebraic expression, stop and ask yourself, could this expression equal 0? If the answer is no, prove it. If the answer is yes, handle that possibility separately. That single question could save you from losing an entire solution and several marks on your exam. Now it's time for the final boss. X squared equals 7. Be careful. This time, the trap looks different, but the danger is exactly the same. One solution can disappear if you rush. What are both solutions? Not one, both. Write your complete answer in the comments before looking at anybody else's.